What recording? We have wasted a lot of time. So I'll just explain back. So once we have imported the data, we have combined the data, concatenated the data into one, loan train and test, shape is 98113. Then we have reset the index because index is not coming in sequence. Then we dropped the index, then we converted into object calls and number calls. Then we have label encoded all other cells except the NA cells. We have encoded them into dummy encoding. Except the NA cells, all other cells have been encoded. Then we have combined the data frame into one. Then we have run the KNN Imputer. KNN Imputer is run on the numerical data. All data points should be numerical in KNN Imputer, where we have run the KNN Imputer. And then we found out all the missing values have been imputed. And then I have converted the KNN data into a data frame so that we can work on it later. Okay, till now everybody is clear? So everybody is clear till now? Now you want some other, there is something called Iterative Imputer. From sklearn dot experimental dot enable Iterative Imputer. From sklearn dot import Iterative Imputer. Import Iterative Imputer. So this Iterative Imputer is as of now in experimental basis. From sklearn dot experimental dot enable Iterative Imputer, import Iterative Imputer, or sklearn dot import Iterative Imputer. Now this Iterative Imputer in sklearn works like mice. So let me show you the code. Iterative Imputer. Iterative Imputer. See? So it is multivariate imputations. So we can impute it now. Loan df iter in is equal to iterative imputer dot fit underscore transform loan df1. It has imputed. So loan df iterim dot is null dot sum dot sort underscore values ascending is equal to false. So again, it has converted into numpy array pd dot data frame. See, there are no missing values. There are no missing values here. So Iterative Imputer is like mice imputer. Iterative Imputer is like mice imputer in R. Multivariate imputation. So you can use both. See, depends. Sometimes you use KNN, sometimes you use Iterative Imputers. So we see it all depends on how accurately your model is working. In R, we get the error metrics also. In Python, we are not getting it. In R, once you run mice now, it will give an error report. Error report means how accurately it is calculating with the original and the imputed data. And if the error is small, that means your data is properly imputed. Here in Python, we are not getting the what you call error report, error diagnostics. But they said they will implement the error diagnostics in the future version. So full version of mice will be implemented in Python, sklearn in the next version. This is experimental. Whenever you see experimental means it is in beta version. So in the next version it will be in live. Then we will definitely get the diagnostic.
Then we have to change the iterative method. We have to
see, we will play with the methods. That's all. Now let us see how much actually. That's what I run both the methods, right? We have run both the methods now. Let us build models on both the methods and then see which method is working well. Okay, so we have imputed the data. This also we will convert into data frame. All of you done with iterative imputer? So done. Now we'll convert this also into data frame. Loan df iterim is equal to pd dot data frame loan df iterim comma columns is equal to loan df1 dot columns. So these are the column names also, right? Now, so first we will split the data. Now we have cleaned the data, right? We have cleaned the data. Now we will split the data into X and Y. Now, Y is equal to, no. We have to split into train and test. Train and test. Loan train underscore KNN is equal to loan df imp KNN square bracket loan df imp KNN dot loan underscore status not equal to test. Similarly, loan test underscore KNN is equal to loan df imp KNN square bracket loan df imp KNN dot loan underscore status double equals to test, right? Then loan test underscore KNN is equal to loan test underscore KNN dot drop loan underscore status comma axis is equal to 1. So we have split the data back and we are what we call drop the data. Now we can split our data into train and test. X underscore KNN is equal to, what we'll do, Y underscore KNN is equal to loan train underscore KNN dot loan status. X underscore KNN is equal to loan train underscore KNN dot drop open bracket single quote loan underscore ID. Loan underscore ID comma loan underscore status comma axis is equal to 1. Right? We have split our data into X and Y. Even we will drop that loan test underscore KNN is equal to loan test underscore KNN dot drop single quote loan underscore ID comma axis is equal to 1. Right? So we have split the data. Now we also have to convert that Y underscore KNN label encode it now is equal to label encoder dot fit underscore transform by underscore KNN. So we have label encoded the KNN also. So we have split the data frame. Then we drop the loan status from test. Then we split the data into Y and X. Then we also drop the ID from loan test KNN. Then we have label encoded our dependent variable Y underscore KNN. You got stuck somewhere? What's going on? Yes. Now we will build multiple models on this data, and then we will come up with the best possible model. Okay, all of you are done till this point. We've got a chat message. Yeah, Rupam, what you did was right, but we are going to build multiple models, Rupam. What you're saying is you're creating a model selection.
Yes, sir.
But here you are taking only one model. We will be working on multiple models.
But sir, after that we can import the
encoding,
random
label
forest.
encoding.
Then we can
Dependent
pass
variable
that.
0 and 1, right?
Yes, sir.
Instead of le.fit_transform, I use label encoder directly.
Yes, sir.
Generally, we give L is equal to label encoder and do it. Now, instead of that, I use label encoder directly.
Yes, sir. Yes, sir. But with this function, we can use multiple models. No, sir? I know what are you talking. You are talking about that pipeline. Right, sir? Hello.
Okay, shall we build the models? From sklearn.linear_model, import logistic regression. From sklearn.tree, import precision tree classifier. From sklearn.ensemble, import random forest classifier. From sklearn.ensemble, import gradient boosting classifier. From sklearn.naive_bayes, import Gaussian naive_bayes. From sklearn.sem, import SVC. Okay, we will similarly from sklearn.ensemble, import stacking classifier. So we will build all these models on our data.
Sir, what is stacking classifier?
That is the model. It will go to all the models and gives us the best model. Okay, so we have to create estimators. Stacking classifier will build all these models and this will give us the best model. Let us do this, then you will understand. Okay, estimators is equal to square brackets open round brackets. First one is what? Logic. Logic, comma, logistic regression, comma. The second model is what? Tree, comma, decision tree classifier, null brackets, comma. The second model is RF. RF, comma, random forest classifier, n underscore estimator is equal to 1000, comma, GBM, comma, gradient boosting classifier, n underscore estimators is equal to 1000, or forward square bracket, round bracket. Comma, bracket, neighbors NB, comma, Gaussian NB, comma, next SVM, SVC, right? We have defined our estimators. These are our estimators. We will use now stacking classifier. Okay. Now, CLF is equal to stacking classifier, estimators is equal to estimators, comma, final underscore estimator is equal to logistic regression, CLF model is equal to CLF dot fit x underscore KNN, comma, y underscore KNN. Oh, we got an error. Oh, cannot clone object logit. Oh, so we have to give logistic regression. Final estimator is logistic regression. So we got convergence problem for logistic regression. So we have to increase max iterations. Compare it to estimator. It will compare it with logistic regression. So we'll see accuracy scores and see what we will get. Coming week we'll have some other sessions. I am not there on Monday, but next Tuesday. So I've already informed. So they will set up some other sessions for you. Maybe soft skills or any other thing. Or I don't know what they will do. So increase the number of iterations. Logistic regression is a failed option. So let us increase the iterations. Max underscore iteration is equal to 3000. Will also will give max underscore iteration is equal to 3000. So estimate. Yeah, it ran for me without error. Now, CLF underscore thread underscore train is equal to CLF model dot predict X underscore KNN. Okay. Now, from sklearn dot metrics import accuracy score. Accuracy score is y underscore KNN, comma, CLF thread underscore train. So we got accuracy of only 65%.
Hello, sir.
Let us see. CLF model dot score No, you're not audible.
Hello, sir.
Yeah. It is right skew. Which data you're talking about? See here, we have built random forest make underscore pipeline, standard scaling, and linear SVC, static layer, estimator, final estimator. We got the values x test, y test, 0.9. Decision function. Predict decision for samples in X. This is final things. So we have stacking classifiers here, but how do we get? No, Y is not numerical. Y is categorical. Opam, Y is categorical. Mm-hmm. 73 you got, huh? Independent variables. Okay, independent variables, we can standard scale them. Yeah. So stacking classifier. We have research also in stacking classifiers. Okay. Independent variables, there is a lot of skewness. CF model dot fit x underscore KNN comma y underscore KNN. Oh, dot score, right? Accuracy is coming very less, 65 only, right?
No, sorry. In CF, we already have the estimate. So directly format score.
As in what you call in R, we used to get each variable's importance, right? Okay, you are saying CLF model dot score, huh?
Score of X.
This logistic event is not fitted at all. Call fit. So first we have to fit. Huh? All accuracies in this case. We want all the accuracies.
So run that command after 60.
Now, one second. CLF model dot classes decision. What is this decision function? Decision function is this. It is doing, but where we get estimators, final estimators, bit underscore transform, named underscore estimators. So we want to model each model's score. Set params also we got, but we are not getting the score anywhere. It's imbalanced data. Yeah. Smart. We have used smart.
Evaluate models.
Evaluate models is there. Huh? Why we got three predictors? In Y we have only two, right? Correct. We got three levels. How come we got three levels? 0, 1, 2. Okay. So the whole thing was when we label encoded them, it was part of object calls. We had a mistake. We did a mistake actually. We should have moved it from object calls to numeric calls. That this one, we have made a major mistake here. So see here, in object calls dot columns, we have this also, loan status also, right? It has label encoded that also. So what we have to do is we have to move this to numeric columns. Numeric calls, square bracket, single quote, loan status. This we have to move to the numeric calls.
Delete from our
Or then we have to delete it from object columns. Is equal to object calls dot loan status. Now we have added it to this one. Right. Now we will drop it from object calls is equal to object calls dot drop loan status. Loan underscore status, right? Loan underscore status, comma axis is equal to 1. Right. Then we will run the object calls dummy. Then we will concat them. Then we will look at the nulls. KNN Imputer, transform, no, that, then Iterative Imputer. Cannot convert Y. Oh, okay. So what we have to do is, before we run this, we have to separate the variable from loan df1. Y is equal to, no. What should we do? Y only. Y is equal to loan df1 dot loan status. Okay. Then we will drop the loan status from the variables. Loan df1 is equal to loan df1 dot drop loan underscore status, S capital, comma axis is equal to 1. Then we have run the imputation. Right? We have done the imputation. Now here we have to add one more column. PD.data frame loan DF in. Okay, we'll add it later. Let it be like that only. Okay, then loan DF in square bracket single quote loan underscore status is equal to y, right? Here we'll add one more. Loan DF iter in square bracket loan underscore status is equal to y. Then, see, we got y and n, right? Now we label and code. Then. So actually we have to move it to, see here, first change is do this. First change is this one, right? So this you have to do. After object calls creation and numeric calls creation, then add it to numeric calls dot loan underscore status. Then drop it from object calls. 1 second, let me check the classification report now. See, accuracy 85.5. See, we got good accuracy. 65. So just work on this, okay? So this is the first change you have to do. You done this change? First change after object calls and numeric calls selection, you add the loan status to numeric calls and drop it from object calls. Best model. It's not displaying. Done? Then next what you have to do is you have to run the dummy again. Run all the lines from there. Loan DF1, then and all imputer. Before running the imputer, separate the loan status. Y is equal to loan DF1 dot loan status and drop it from, because if that is the problem, no, imputer is not running on both number and text. No, it is Y is both 0 and 1 and test. It's a combined thing, right? 0, 1 and test. Hey, who is betting here? Who? No. Who is batting? First match is Australia versus South Africa, right?
Australia.
46 for 4. I told you, na? This can happen with India also. Yeah. Who are out? See, was actually we were trying to do one of my friends. We were trying to argue. We were discussing How do we make a model? Who has the probability of winning based on the T30 recent 5-year T20 wins? Recent 520 wins, T20 wins and scores,
That means,
highest score and all we can get. That data is there.
why will you get it? Go to the points table, we will clearly state number one, that team will put,
You are basing on that.
if we done the model also, that will only matter. Take the lot 5 years matches. Who will do most mean, he will get the top points. He will stays in the first position. So of course,
There, yeah, he is right. You are taking winning only, no? You are not taking losing here. There, losing also we have to take into account, no? The points will take only winning.
don't take, didn't take.
The
winning
point-
side. It takes the like average points, like
No.
winning only, winning percentage will.
See,
stays
what
on
it is, India will win, right? 1 or 0. It is taking only one impact. It is not taking the 0 impact.
If we give, according to the winning percentage, the ranks will be assigned.
And that is different. We are trying to predict a model based on the last winning, how many they won, how many they lost.
Based on
What
the-
was their average first super power play score? How many wickets were lost in power play average? All these things we have to take into consider. So one variable will be what is the average power play score first 6 hours. Then average 6 to 15 average. Then last 5 hours average. Now how many wickets on an average fell in first power play? 15 to
If we
days.
use that data, we can predict for 1 match.
No, all matches. We have to, for all teams, all matches.
If we take last 5 matches and we.
No, that is too small of data. What you are saying is the percentages. You are doing a simple calculation. What I am talking about is a machine learning model. Actually, FIFA World Cup that used to happen in investment banks. Internally, we used to have a challenge. When I was working in UBS, Swiss bank, there we used to have an investment bank. There people used to bet with models to predict who will win the World Cup. And the bank will give the person $500,000 prize if his prediction is correct. But in the bank's history, nobody won that prize. Based on the model. What are you predicting? I will say Brazil will win, Argentina will win. No, it's not like that. You have to take the matches, the data will be given to them. How many matches each
The
country
luck is
played.
included, then
So that is what process is all about. See, simply guessing or betting is nothing, right? Otherwise, what is the job for us, data science people? See, if you want to run a betting site, you need to have all this data, right?
7.
See, villages slow betting different. Villages slow betting is like, gut feelings. But when you are running a bet company,
Based on the statistics.
Rupam, I have seen it. I have seen that thing, Rupam. I have also calculated. 1 second, Rupam. I have also calculated it. Where I calculated it? Rupam, based on that, it was type. Type is the root node. Type is the root node. I will check your file also. I checked it. Sibanand showed me in the morning. Sivanand showed me in the morning. Sivanand showed me actually you can't build a tree from that data because all the information given are very less. Only type is getting 0.12 or something, rest of all 0.02. What you have done is right. So here you have calculated same 0.9, 0.291 for other two, 0.1246. Even I got the same. Type is the root node. Exactly same calculation I have done in Excel. I also got the same answer. These two are same because 2332 entropy and all are same. So the root node will be type and you can't build a decision tree. Yeah. Morning I did it. Actually, Sivanand was also doing it. So I did it in the morning. What your calculations are right, absolutely right. So the information gain of type is 0.12. Root node is type. Other file, you send me this Word document. What is this? Maybe you send me the wrong file. Okay, you want to add anything on this one? So you have to add the assumptions. You have to add the assumptions. You have to add all the assumptions, 4 assumptions on that one. Multicollinearity, assumption of linearity, assumption of exogeneity, assumption of sample size for linear regression, then the residual assumptions, homoscedasticity and normal distribution of residuals in regression. So you have to add the assumptions. 4 pre-model assumptions, 2 post-model assumptions. Got it? Yes, you can add all those things. But assumptions are critical because multiple linear regression is a parametric model. Multiple linear regression is a parametric model. Parametric models, assumptions are very, very important. The definition of a parametric model is there are prior assumptions to be to be taken into consideration. Whereas K-nearest neighbors is a non-parametric model. KNN is a non-parametric model. That means there are no prior assumptions for data. So you have to talk about assumptions in multiple linear regression. And how do we check for the assumptions? Got it? Yeah. Sure, we can create a notes. After that, same thing you add it to the data frame. We dropped it now. You have to add it now back to the data frame. Convert the into KNN into data frame and then add it to data frame. Then iterative imputer. Bavuma. Quentin Decock is lost. Quentin Decock, David Warner, all of them failed, right?
No, somewhat okay.
Vander Dusen, Ed Markham, Klassen, David Miller. So Maxwell got 1 wicket, 2 for Hazelwood, 1 for Cummins, Zampa 0. I think these teams are in our group, right? No, not our group.
Lanka, Pakistan.
So they went with two spinners, Keshav Maharaj and Tabrez Shamshi. Sheikh Zayed Stadium, Dubai. Dubai is Dubai, but okay. Artificially built, concrete. Nowadays, the economy is surviving because of this only. Since hotels are full in Abu Dhabi, sorry, in Dubai, because of the T20 World Cup. Indians are also going in groups, all Indian matches.
Cannot be indexed from the
Same problem, reset index, the top. Oh, shit. Shit. Krishna, you hit me hard. Ramakrishna, next week, Tuesday not available. Only on Thursday I am available. Only Thursday. Let the cancellation other week pattern. Okay, please. Okay. Right. Reset index, which one you are using? No DFM KNN? Then where is the index there? That means your Y is smaller. Either one is larger and the other is smaller. That is why you get the duplicates. What is the shape of Y? What is the shape of Y? It's not status also inside. Long and medium.
Run again.
Loan BF1 into KNN, where that is equal to so there is no such thing like here. Another research. Loan BF is 1 by 1, right? Don't say that is not there. It's one BF1. There is no loan BF here, right? So there is no loan BF here. Numeric problem. Problem is this one. Numeric problem, square bracket, loan equal to object calls for loan better. Right. Object calls is equal to object and numeric calls down to get done. Now we got one statement. Actually, there was some spelling mistake or some spacing error might have come up. Yeah. Where is Now let's say duplicate access. Then here move from there. Okay. Then do KNN. Five hours later. That is why it's struggling.
For the KNN Imputer, we got that error, but to use Iterative Imputer, we didn't get much error.
I'm not sure. I didn't check this.
Oh, we got the error because of that label encoding one. But in this
Just check once.
for this one, you're getting number of iterations each. How to change the iteration, sir? Warning message. Reduce. The total number of iterations each limit. I am given 2000, sir.
Who will come and match
Tomorrow.
today? Oh, today, no?
Today 23rd.
Alumni meet, our college. Value. I'll start getting calls from private, are you coming or are you coming? Instead of drinking there, I will drink at home watching match. That is the best option. There also, all people will join around cricket match only. I said yes or no, maybe. Placement season start now. They give party to alumni at the beginning of the placement season and after the placement season. Let us see. I don't know, I was part of this group also. IBS 03 HYD. Oh, Srividya is there, Prashant, Gunjan, Vikash, Anatosh, Vikas Jain, Ashish, Abhishek Mehta, Rajiv, Vikas Ketan तो पुणे चला गया. Don't?
Warning message to 93.
Warning message is okay.
And score is 90.
Oh, you got score 93, huh?
1000.
1000. 1 second. KNN imputation.
Okay.
Iterative imputation in stacked models. So, R step, sorry, I got 85 here.
Okay. Go. Down to 120. I did score for XNN and KYN. After 119, and directly set up model dot score of X underscore KNN, Y underscore KNN, get to 93.
Just in here, right?
Scale of model dot score.
Scale of model dot score X underscore KNN, comma Y underscore KNN. 85 only I got. That accuracy scale is 85 only I got. Classification report 86 with recall is less than 0. So slightly overfitting. Slightly overfitting is there.
So why this 126?
Accuracy score.
Oh, we already got
We got score also. There is a function called accuracy score also. Actually, we don't need it.
So getting the score only.
Score only. Yeah.
If we didn't have, we can leave the
This, yeah, that is not required.
class from classification report.
Yeah. We need to predict also, right?
We have to predict.
So test predict is equal to CLF model dot predict. What was our data? Loan test, right? Underscore KNN.
No, sir.
Loan test underscore KNN. Yeah, loan test underscore KNN. So test predict. What are the values? $205 62. Test data. Did we get the same thing on train data? Dot value counts dot to underscore CSV test square dot CSV. Let me just check now once whether we got a good one or not. Hackathon. Analytics with the loan prediction, sample submission. Oh, we have to convert them in zeros and so is equal to here is equal to 1, yes. So y and n, capital Y and capital N. So is equal to y, comma is equal to n.
Otherwise, we can change it in Python.
I can change it in Python. So Control C, sample submission, Control V. So they are formulated cells, no? So C, sample submission, paste values and number formatting. Yeah, Control yes. Okay. So let me submit the loan status once. Check what is our accuracy. Solution checker, upload file, desktop, hackathon, AV, correction, sample submission, open, stat, .77.083 permissions. Leaderboard. Leaderboard 1. How can they get 1? $6,891. One getting is impossible.
How to change it here means that Python.
They are used, I think they are using XGBoost and all those things. XGBoost, LG Light Boost, and the Cat Boost.
Oh, no, sorry, answer we got Y and M.
Here you just need to use if else, huh? No, if so. No, np dot where. np dot where row is equal to 0 something is there. If doesn't work here. Here, right? So np dot where. So test credit is equal to np dot where test credit dot square bracket 0, right? Is equal to 1 double equals to 1 y and test credit only one came, huh? Yeah, only one came here.
You can write 2 sentences.
No. Map is there. So test predict will write it and then we remove this. Test predict you got ones and zeros. Test predict dot head. No. This is array, right? So in an array, test predict dot map. There is no header, no? It one is equal to y, comma, 0 is equal to n. Perhaps you meant double equal to, huh? NumPy has no attribute map. Oh, NP dot where test predict yes, comma no. Sorry. Hey, cutted it. Huh? How to get back the cell? How to get back the cut cell? Yes. You got it here. NP dot where simple. Then you can push it. So file download as